All right, this is section 1.2 of JV statistics, and this is about stories categorical data tell. All right. Although section is long, a lot of things in stats have a tendency to be time consuming, but not particularly difficult. And this is one of those things. And there's a lot of vocabulary building. And again, it's very easy, but it just may be new to you. So that's always my battle cry in stats is that it's all common sense. You just have to learn the language of the common sense. That's really all it comes down to. All right. So section 1.2 notes, we're talking about frequency versus relative frequency. Okay. And frequency is just the actual count. And relative frequency is the proportion, fraction, or more commonly the percentage. All right. So when obviously you're going to use relative frequency, as I pointed out here, when you got populations of different sizes. It sounds so basic, but it's literally the reason that percentages were invented. So you could compare things of different denominators. It's just that simple. So, but we often call it relative frequency. Okay. All right. So, as I always say in any of my videos, these are meant to stop anytime you need to. Some people will want to work out the problems ahead of time and then look at them. Other people will want to do them at the same time. It's just really up to you how you want to handle this, but feel free to stop this video. I don't need to hesitate or pause because you could do that on your own. All right, so the first one we're talking about, which is more appropriate, frequency or relative frequency. So you get 8 female students and 2 male students got an A. There's 20 females and 4 males. Which one's more appropriate? Well, what's more appropriate in this particular case, because the denominators are significantly different, is going to be the relative frequency. Okay, because the females win 8-2 if you just go raw totals, but by percentages, the males obviously have the advantage. All right. Now this one, you got 50 honor senior students and 50 non-honor senior students. Okay. And the totals are very, very similar. You could really use either one. I said either one. Most people will just use that one because the denominators are the same. But again, doesn't make much difference. All right, C, you got 43 of 46 kindergartners believe in Santa Claus and 12 of 42 sixth graders. They're pretty similar denominators, but I would go with the relative frequency. You can see the percentage drop there is tremendous, from 94% roughly to 29%. Okay, and then D, got a couple schools with tardy issues. Los Amigos has a lot fewer kids than La Quinta has, LQ, but they each had 34 tardies. But percentage-wise, that's going to favor La Quinta. And again, because the denominators are different, you're going to want to look at that. All of that is really common sense, okay? But it just takes a little time to get through and analyze, no problem. All right? So let me scroll down here. Now we got a bar chart, okay? Now, you're eventually going to learn you got bar charts and histograms. They actually look the same. It's called a bar chart because it uses bars, okay? And a histogram also uses bars. What makes a bar chart is that it's for categorical data, because those car types are categories. If they were numeric, like 1 to 10, 11 to 20, 21 to 30, etc., then it would be called a histogram. Okay, histogram is when it's numeric. When it's categorical, it's called a bar graph. Very small distinction. It's a Kleenex tissue kind of thing. Even if you made a mistake, it's not that big a deal. Okay, and then you got your pie chart. Okay, you got your pie chart there. And that's pretty simple. You got to turn it into degrees, which can sometimes be problematic. Pie charts are not actually all that common in statistics. Segmented bar graphs are really common. And of course, they're called segmented because, hold on a second, my wife's phone is ringing. Okay, crisis averted. All right, so segmented bar graph, like I said, it's a bar chart cut into segments. It's pretty obvious where the name comes from. They're often color coded, or in this case, because it's black and white, I striped and dotted things. But you get the idea on that. It makes it easy to compare. Okay, so that's a pretty easy one as well. And then you got a table. Sometimes it's called a two-way table. Okay. Oh, by the way, the area principle up here. Make sure that these charts are built percentage-wise to correspond to the value. Don't cheat on those and make it look funny. So I'll have examples of that later. All right, a contingency table is often called a two-way table, where you got two different things going on horizontally and vertically. And these are called cells in here. I don't know if you don't need to write it 30 times, maybe just write cells. These are marginal totals because they're totals that are located in the margin. Okay, that's obvious. This is called a table total, lower right-hand corner, because it's the total of the table. I mean, it couldn't be any simpler than that, okay? And you get the idea that you can, again, pause it and write this down anytime you want. Okay, so let's get to this question here. All right, percentage of students who are male and received an A. When you see the word and, typically they are talking about both horizontal and vertical. So you're going to use the table total as your denominator. So male right here and received an A, both qualities, male and received an A, okay? Then on the second one is percentage of male students who got an A. So you're just talking about the males now, just the males who got an A. You're just here right now, males who got an A, okay? So there's no and there, so we're talking about 12. This is a marginal distribution, okay? Because it's a distribution that has a marginal total in the denominator, okay? And then the last one, percentage of A students who are male, okay? Percentage of A students who are male, okay? A students who are male, and that's going to be 4/11, as you can see there. Okay, not super hard, but they do come up. And there's more complex things that we do with these tables. This is all pretty simple, but sometimes it takes time to get the answer, even though it's easy. Sometimes it can be time consuming. All right. Okay. Now we got a bar chart again, and again it's called a bar chart because we have categorical data. The categories are the months. Those are not non-numeric, okay? So which month had the most sales and the least sales? I went ahead and labeled all the numbers there for you. So most sales was May, okay? And least sales was January, pretty easy to read, okay? And the second one, how many more arrangements were sold at the start of the summer, June, than at the end of the summer, September? So you're going to take June's total, which was 80, and go minus 40, and that's 40. Again, no problem, okay? And the last one is, what percentage of annual sales did February achieve? So February had 100, that's Valentine's Day for flowers, you know that. 100 divided by 720, and you get 13.889%, okay? Maybe, is there another question down there? I forget. Let me look real quick. No, okay, good. The next one, move this over, is we got a survey of 300 cancer patients, okay, by alcohol tobacco use. Okay, what percentage of these cancer patients use tobacco? What percentage of these cancer patients use tobacco? So these are the cancer patients that I have totals in there, okay? Now, how I got the totals, by the way, I had to do a little bit of work ahead of time. I had to take 3,000 and multiply it by every percentage. I'm sure you figured that out, okay? Okay, so what percentage use tobacco? All right, so I'm gonna go, the percentages would be 73%, okay? So it's gonna be this one, these two right here, okay? The second one, how many of these patients used alcohol but didn't smoke or use tobacco? How many of these patients used alcohol, but didn't smoke or use tobacco? So that would be right here. That's just alcohol only. So I just took 3,000 and multiplied it by 0.15. And the last one, how many of these patients use tobacco? Okay, use tobacco, and it's 73% use tobacco because it's both here and here. So I went 3,000 times 0.73. I got 2190. Okay, all right, pretty simple. So far, so good. All right, the next one, we got C and D here. I got a segmented bar graph. This is kind of cool. I got this data in 2013, as you can see, from the military spending. It's a little old, but that's all right. It's still relevant. How much money we spend on stuff. I mean, it's unbelievable how much money the U.S. spends on military spending because we're kind of seems like the world's police at times, but that's a side issue. All right, what percent of the total education budget belong to France? Belong to France. All right, the total education budget. So what I did is I went ahead and I labeled, as you can see, all the segments. And this would take time. This would take a little time to get these numbers. Okay, that's not like, and it's a little bit of an estimate. You may not be exactly sure, but you can see that. And it's the same for the US as well. The US and France have the same amount for education. Okay. And then the second one, what percentage of the total military budget belong to France or the US military? Wow. So the US, that's a massive amount of military spending. Okay. It's 57% of those 4 particular countries. Okay. And then the next one, what country spent the least on both education and the military? And that would be Russia. Okay. You can see that right there. Okay. Check down here. Oops, I got a couple more questions. I gotta make this a little smaller, maybe. There we go. It's a little harder to see, but I think we got it in there. Maybe make it a little bigger now. Okay, I think I got it in there. Okay, compare the total spending on education and military. You know, they're somewhat equal. I mean, these are massive numbers, but they're pretty equal. Is what I said. I mean, you could say one's more than the other as well. No big deal. Okay. All right, and then compare each individual's country spending on education and military. There's a lot of ways to write this. I said U.S. spent 3 times as much on military than education. China spent more than twice as much on education and military. Russia slightly more on military. France spent twice as much on education than military. That's what I said. I mean, so there's other ways to do that as well. All right, next question. I believe this is the last one of this particular section. All right, survey of favorite sport by gender. This is completely fictitious data. I remember I just made it up just to have something, okay? What percentage of those picked basketball as their favorite sport? Of course, I love basketball, so I put it a little higher. Okay, so I did, what I did on this case was 36 out of 135, okay? And then the second one, what percentage of those surveyed are men who favored baseball? Are men who favored, again, you're talking about 2 qualities, men who favor baseball, okay, male baseball out of 135, all right? Okay, next one. What percent of men favored baseball? Now you're just talking men. So this is the denominator right here. And the numerator will be the baseball one right there. Okay. What percentage of those who favor baseball are men? Those who favor baseball are men. So those who favor baseball, okay, are men, which is going to be right there, 14 out of 26. All right, is there an association between gender and soccer preference? Association. So what we're going to do is we're going to get 2 percentages. This is a little harder question. Gender and soccer preference. Okay, so here's soccer. So the men are 9 for 65. And the women are 16 for 70. So if you make those into percentages, the men are about 14% and the girls are about 50% higher. And a lot of that's the dominance of the women's national team. That was my thinking in making up this data. So I put women prefer soccer at a higher rate. All right. So take your time on those. This is not meant to be difficult, but it does take a little more time than you might think to do this. All right, that is section 1.2 of JV Statistics. Catch you next time.